It's good to be here. So, yeah, hi everyone. I'm Andy Moore, as you just introduced, Senior Marketing Manager at RISC-V. I'm going to give you a short overview of RISC-V and why we think it's so important for the future. I mean, some people have mentioned it already. You know, it's an amazing time for RISC-V. We've got lots of technical innovation, lots of momentum. You know, we're seeing that translate to success in the marketplace as well. And you know, our huge ecosystem of members is already accomplishing great things, and we're really just at the beginning. So I'm preaching to the converted here, I'm sure, but the thing that brings us together as, you know, societies and colleagues and engineers and developers is, you know, when we encounter challenges, what's common across all these things is we solve them through collaboration, and global standards have underpinned the most important technologies in computing history, for things like USB and Ethernet to web standards like HTTPS. You know, these standards, they level the playing field, they allow us to innovate, and enabling us all, from students to corporations, to move the state of the art forward, to compete effectively for business and to foster and encourage innovation. Standards are really important to technology, and RISC-V is the open standard instruction set architecture, which is enabling a new era of processor innovation through open collaboration. RISC-V enables our community to share technical investment among the community and contribute to the strategic future, create products more rapidly, and enjoy unprecedented design freedom. And this substantially reduces the cost of innovation for everyone. So let me put it another way. The definition of open computing is RISC-V. We are the most prolific and open instruction set architecture in history, and we believe that RISC-V is inevitable. You know, across computing, as we see worldwide adoption from the lowest power embedded applications to HPC and data center, you know, people are excited to unlock new possibilities using RISC-V, and we see investments in innovation and adoption across the compute spectrum at every performance point. And some analysts that we're, you know, speaking to are saying that it's hard to find now a design start that doesn't include RISC-V. So this is really a critical point in compute history. And as we've seen before with open source software, open standards are taking hold, and we're engaging an entire ecosystem to grow much faster than we ever have before. And that's why we think RISC-V is inevitable. And RISC-V also enables the best processors by design, so other architectures can be a poor fit for what you're trying to do. They give you baggage and features that you don't need, or they don't let you enable custom features that you do want. And by taking a truly modular approach, you have much more freedom in your design, enabling you to be more competitive, more differentiated, and tackle challenges that you couldn't on other architectures. RISC-V also enables you to achieve your targets in terms of performance, power, silicon area, and enable your specific workload. It gives you the variable of design freedom not possible before, and this flexibility and freedom increases your potential for innovation. So by using RISC-V, also you have the support of a massive community, enabling you to concentrate on your innovation specifically and putting your efforts into that. RISC-V is rapidly building the strongest ecosystem, and we have collective investment from across our membership. I'll talk about this a bit more later. We're taking a very thoughtful approach to support this ecosystem, and you know, for one example, we're specifying a single hypervisor standard to simplify and unify application support. And we also have already 10,000 software developers working on RISC-V already. It's taken other architectures decades to accomplish what we've been doing in basically just a few years. And this is made possible by the collective investment of our community, all working together. Oops. Oh, sorry, wrong button. So, as a community, RISC-V continues to grow very quickly. RISC-V membership was up 28% last year. You can see from this graph and how this has accelerated over the last few years. We're now over 4,000 members, and they're divided equally around the world, with about a third of people in America, 1/3 in APAC, and 1/3 in Europe. And this is because we're consistently engaging globally across the whole world. These global contributions from the RISC-V membership to our projects and other existing projects enable us to all succeed together and be competitive on the world stage. So another graph showing a similar kind of trend here. RISC-V is on an amazing growth curve. We're growing at more than 40% And yes, the lower numbers, and we're starting from lower numbers of shipments than other architectures, but this growth is really amazing, and we haven't seen something like this before in compute history. We'll be seeing about 16 billion, we'll be in 16 billion SoCs by 2030. And note that we're talking about SoCs here. So as we all know, there could be multiple cores in each SoC depending on what they're doing. So this could mean a much larger total number of cores shipped. These numbers came from a report from the SHD group that came out late last year. If you want to have a look at it, it's on their website. It's 80 pages long, and it really offers an in-depth and unbiased analysis of where RISC-V is going and the trends for the future. I'll show you some of the information from the SHD group here. So this is their market share projections for RISC-V in 2030. You can see that across all these different spaces, from small wearables and MCU to advanced automotive and AI applications, everyone is looking at RISC-V, with substantial market share expected by the end of the decade. RISC-V is it's cementing its place and its position in computing for decades to come as the most profound revolution that we've seen in processor technology. So you can see, the numbers are pretty big for RISC-V. Wearables and MCU, nearly 30%. Computing and notebooks, 22%. Communications and infrastructure, we were hearing about this morning, 20%. Automotive and AI, which have quite long design cycles, and I'll talk about in a minute. We're looking at, nearly a quarter. And consumer AI acceleration, 36%. These are really big numbers for us in, 2030 suddenly doesn't look that far away as we're in 2024. Some interesting new processors that have come along recently. We've heard a lot about Cherry this morning. Codasip, one of our members, have come out with the first commercial Cherry security implementation. Semidynamics, a really interesting company, have got specific RISC-V based tensor units for ultra-fast AI solutions. We have some data center IP from members like Ventana. They have a chiplet solution. So interestingly, you would put your SoC together by incorporating chiplets together and connecting them together. They have a really high performance CPU solution there, which has up to 192 cores. We have in markets like automotive, which have really stringent requirements in terms of safety. Already there are RISC-V based products out there, like from Nuclei. Their NA900 has been certified compliant to ASIL D of ISO 26262. So that's that's quite a stringent standard to be certified to. And Tiempo Secure have passed this security test. I don't know exactly what the security test is, but we have people working in security and safety, which are both quite challenging areas as well. This is kind of an interesting one. This was ICT, a team of researchers. They used AI to design a RISC-V CPU, so it kind of designed itself in 5 hours. I think the performance, I'm kind of dating myself, I think is about relative to a 486 x86 CPU, but it's worth having a look on the internet for that. It's quite an interesting little project that they did, so that was quite cool. So applications, we're seeing RISC-V being applied all over the place just now. So you may have seen last year, Qualcomm announced that RISC-V they were going to partner with Google for using RISC-V in their Google Wear OS. Esperanto AI have a really interesting chip. It's a 1,000-core SoC for doing AI type workloads. Cyped launched a RISC-V tablet, and we also saw a notebook from Deep Computing. So there's actual consumer products out there. There's also like soldering irons, model cars, other things already that are based on RISC-V silicon. So this isn't just coming, it's already here. There are already products based on RISC-V. At RISC-V Summit in North America, we were showing the Milk-V Vega, which was a 10 gig Ethernet switch based on RISC-V. So again, another product already out there. Town Gas, they have sold over 1 million units of their RISC-V based IoT security chip in China. And Meta, this is an interesting blog to go to and have a look at if you have some time. They have been talking about their first first generation AI inference accelerator, and that's based on RISC-V. They took the ISA and they made it did what they want, and yeah, it's being used for their AI inference accelerator. So there's loads of really interesting new applications coming out all the time. So to speak about developers for a minute, developers are the people creating the workloads and the products of the future. And there's a lot for them to be excited about on RISC-V. We're working at RISC-V International to accelerate the opportunities for developers and give them an easy on-ramp to develop on RISC-V. We've heard more and more about people supporting RISC-V. So, for example, Android. At RISC-V Summit in 2022, we heard that patches were beginning to be accepted for RISC-V. And then at RISC-V Summit last year, Lars Bergstrom from Google spoke about how they will begin to mature support from RISC-V and Android. If you're interested in more about this, go to the RISC-V YouTube channel and you can type his name in and you'll see a couple of talks there. There's lots that you can watch there. In other operating system news, Debian is now officially has support for RISC-V, and we see new tool chains and SDKs, simulation technologies that are enabling the testing of software before the physical hardware is available. So, like Imperas will enable simulation of software before hardware is available. And yeah, we also see really low cost development platforms to target. So MuseLab, there's this Nano chip, which is a sub 10 cent RISC-V based microcontroller with a $1.50 dev board available. It's really, really exciting. We had at RISC-V Summit North America last year, we had a dev board section and we had 40 dev boards from across the ecosystem. We're going to be running that again in our RISC-V Summit in Europe. So if you're going to come to that in the summer, you'll be able to see some of these things. So I want to talk specifically about a few industries and how RISC-V can help with these industries. So for example, first, automotive. Automotive is undergoing a time of great change. I'm sure you've seen from the cars that are becoming available and the features that you're seeing there. Our cars are becoming more and more defined by software and by computing. The automotive supply chain has really got kind of interested in the last year and a half and see the opportunities that RISC-V can offer in a highly competitive and changing market where everybody's kind of looking to cement their place and where they can innovate. The automotive supply chain is changing a lot. People used to, the OEMs used to speak to the tier one suppliers and they would supply boxes, and they would speak to the silicon providers and they would supply the chips for those boxes, and it was all kind of, everybody knew where they were. Now, because vehicles are becoming defined by software, some people are thinking of building their own silicon, other people are looking at what services that they can build in. It's really kind of all up in the air. And so what we think RISC-V will offer them is it enables the automotive ecosystem to work together, to talk the same language on the same ISA, but also offering them ability to innovate and differentiate. And they need both those things. They need the sort of security of working together, but also the ways of innovating individually. The RISC-V ecosystem has extensive capabilities across hardware and software, but we also understand the specific requirements of the automotive industry for long-term support. It's different to other industries, and we have some of our members working on products enabled by RISC-V that have this long-term support, but also using RISC-V enables easier multi-sourcing for these companies, so they can have different options for silicon, but that are all based on the RISC-V ISA, so they're all kind of have compatibility, but yeah, they can source from different places. So you can find lots of different options for automotive based on the RISC-V standard. Next up, data center and cloud. Cloud computing, obviously key to so many workloads in our everyday lives, and RISC-V can help here. It can enable the architects of data center and cloud systems to think more about custom hardware for their workloads. I was just speaking about Meta just a minute ago. So they can think about custom hardware for their workloads in a way that they might not with other architectures. And these accelerators they could develop based on RISC-V enable custom computing for AI and other emerging cloud workloads that increase performance, reduce power consumption, and result in better user experience and lower cooling costs. And we're seeing here below, SHD Group estimate that the RISC-V CPU core market will grow 115% compound annual growth rate, so capturing over 14% of all CPU cores in data center by 2025. Moving on to telecom and consumer devices. this is a key market for computing. I'm sure all of us have got a smartphone in our pockets or in our hand. It's not just about the hundreds, the billions of handsets that are used worldwide. RISC-V can catalyze innovation across the industry, including base stations. So it's not just the smartphones; it's the infrastructure as well. So SHD Group again estimate that RISC-V will capture 20% of communications 5G infrastructure by 2030. As I spoke about a minute ago, Android support for RISC-V will enable developers worldwide to easily target RISC-V-based handsets, and the customizability of RISC-V will enable new innovations. As you know, there are a lot of different SoCs inside a smartphone, so you have your application cores, you have your real-time cores for the communications, you have different MCUs talking to different sensors or screens and other things like that. There's all these different cores, and RISC-V will enable a new wave of innovation by enabling more innovative and kind of specialized cores and features for all these different cores in the smartphone. So we should be able to, as I say, catalyze some new innovations in handsets as well as the infrastructure. IoT continues to also be a growth space for RISC-V. We're looking like capturing over a quarter of this market by 2025, which is that's only a year away. In terms of other numbers, Omdia Research estimate that the number of RISC-V processors shipping into IoT will approach 20 billion by 2028, which is an amazing volume and scale in a short space of time. Energy efficiency is a key care about in IoT, and RISC-V enables a streamlined instruction set where you need it and compact code to give improved performance while conserving energy. And RISC-V also enables customizability for localized workloads like sensor processing and security. Security starts with transparency, and RISC-V enables and allows for transparency and building security across all our workloads. It's something that we've been working for more than 10 years. High-performance computing is a really interesting area also for RISC-V. HPC is on the leading edge of technology, obviously demanding the very highest performance from highest performance from processing. Alongside this high performance, the varied workloads and application spaces for HPC mean that specialization is important, as is the flexibility of the IP used to design the compute power. As I've described for the other application spaces above, the customizability and modularity of RISC-V enables new innovative solutions to be developed to address the varied workloads of HPC, flexibility not possible with other architectures. HPC is tackling grand challenges that make demands of processor technology, big demands of processor technology, demands that take worldwide expertise to solve. And the global nature of our ecosystem and our member ecosystem is custom made for this task. And with RISC-V being an open ISA, it perfectly complements open source software to create an open ecosystem for HPC. The RISC-V community and ecosystem are rapidly growing, accelerating industry in both research and industry. So I was at an event the other week called High Peak, where we were talking about HPC, and there's some really interesting organizations working on this. We've got the Barcelona Supercomputing Centre involved in the EU pilot eProcessor and EPI projects, as well as the DARE initiative. We've got the EPCC, which is part of Edinburgh University, who have been doing cutting-edge supercomputing research for over 30 years, and they are hosting a RISC-V-based test bed, so they're taking the different boards that are available and testing those and seeing how they could work out for HPC workloads. We have also E4 Computer Engineering working on some projects. I think they've developed the Monte Shimone cluster based on RISC-V. So that's, again, looking at enabling co-design of high-performance scientific and engineering applications, and also the supporting software stack. And ETH Zurich, I think were mentioned earlier, and the University of Bologna have been working on their open scalable hardware and software research platform, PULP, for 5 years now, producing multiple designs. just to show some high-performance processors, I've talked about the Esperanto 1000 core SoC. That's really interesting. We have the Ventana part that I was speaking about before. Softgo SG2042. Their SoC features 64 RISC-V cores and up to 32 PCIe Gen 4 channels. This is actually available now. If you go to the Milk 5 website and look for the Pioneer box, you'll see this kind of cool box that you can use for development now for kind of high performance and data center type applications. So there's stuff already out there to work with. So RISC-V International is looking to help our members by building the strongest ecosystem. I'm sorry, this is a little bit fuzzy here, but this is a view of some of the technologies that are available in our ecosystem, from software applications, libraries, hypervisors, and operating systems to hardware implementations like IP, chips, single board computers. And, every time I copy this off onto a slide, everything gets a bit smaller, and there's more things on the graph. If you want to have a look at this, you can go to landscape.risc5.org. You'll see the kind of total market cap, so $5.5 trillion, the funding of $8.5 billion, and you'll see all these different projects. Greg, you're here. So yeah, this is really worth having a look at. As I say, software technologies along the top, applications, libraries, infrastructure runtimes, and down the bottom we have more of the hardware, so design verification and implementation. So implementations in IP, but also single board computers, accelerators, chips that you can already buy. These are all along the bottom. So if you want to have a look at what we have, to offer, then this is a good place to start. There's also something called the RISC-V Exchange as well, and you can go there and type in what kind of thing you're interested, or filter by board or IP, and go and see what different technologies we have. In terms of other developer programs, hopefully some of you here are interested in development. We have sort of three development programs to help. To encourage the development of the ecosystem, to encourage the development of software and software components that will kind of lift everybody together. The RISC-V Development Partner Program it recognizes the investment and dedication of organizations who have made a significant technical contribution to RISC-V. And this program streamlines collaboration between these organizations, and it works to advance projects that the RISC-V task group have identified for extension ratification. This program gives developers, development partners, the opportunity to learn and be part of groundbreaking and innovative projects, and provides a platform for public acknowledgement of the work that they're doing. The RISC-V Developer Boards program is serves to evangelize and to promote the RISC-V architecture by giving out development boards for specific workloads. So if you have a project or something that you think, okay, I want to port this this bit of software, this project to RISC-V, then you can kind of apply to the RISC-V Developer Board program. We're giving out, I think we're giving out maybe a couple of hundred boards, I think, maybe this year. So you can apply there, and we kind of give out boards to the people that we think are going to really make a difference by, as I say, porting software components and doing new stuff. And the other thing that we also have is RISC-V Labs. So this was launched last year, and this is a new program to grow the open source software ecosystem and accelerate developer efforts worldwide. What it does is it brings together companies from across the ecosystem to give developer resources to build and test their software. So that could involve giving them time on an emulated instance of RISC-V technology, or it could be giving them remote access to a physical board. We have, I think, 4 companies working with us. None is we don't have any ratified partners, but there's a blog on the RISC-V website where you can see the members who are working on this with us. And if you have a workload, again, that you would like to try on RISC-V, you can apply for compute time with one of these members. 10x Engineers is one member that I worked with last year. They have a blog there detailing on how to get set up on their system and how to apply for compute time. So if you want to start porting things or playing around with moving your software workload to RISC-V, RISC-V Labs, RISC-V Developer Boards, these are ways that you can do that. And as well as talking about the compute resources, you also need the knowledge. So if you're interested in finding out more about RISC-V and getting some training, we have a lot of different courses and certification. And this has been going since 2021, and we have had over 26,000 registrations since then. There are a variety of courses. So there's things like RISC-V Fundamentals, which gives you kind of the basics. We have stuff on building a CPU core, but we also have stuff on toolchain and compiler optimization, microcontroller applications, or learning the basics. And so what we're trying to do here is, if people who are kind of just starting their journey in terms of development, they can learn the basics here. But also, if you're a seasoned developer, you're familiar with other architectures, you can take these, take one of these courses to kind of sort of just get where this all fits in RISC-V and just get the lay of the land, so that it'll kind of accelerate your path to being able to use RISC-V. Another project I'd like to just mention briefly, this is RISE, the RISC-V Software Ecosystem Project. This is a project which launched last year, and it's focused on commercial software readiness. So it works in close partnership with RISC-V International, and is working to expedite delivery of innovative RISC-V products into the market. So they're looking at target markets such as mobile, consumer electronics, data center, and automotive. And so it's aiming to accelerate the development of open source software for RISC-V and raise the quality of RISC-V platform software implementations, and push the RISC-V software ecosystem forward and align ecosystem partner efforts. You can see some of the companies involved with this. RISE has a website as well, so if you want to go there and have a look at that, you can. Running out of time, I will just say quickly, basically, if you would like to engage with RISC-V, I think there's probably a lot in it for you and a lot in it for us. So there's hopefully people here today who are already members and engaged. Well, we know there are. Thank you very much for your efforts. We appreciate that. For those who are not members, I hope you can see that there's a lot of value here. There are lots of different ways. Oops, sorry. Back. You can elevate your industry leadership as a company. We develop RISC-V within work groups, so the special interest groups. So you can deepen your expertise by being part of these. You can show technical and industry leadership and engage with with the global reach of RISC-V. By somebody like me in the marketing department, we can amplify the stuff that you're doing to the world and get you more visibility. You can build your network by as I say, working in the working groups and working with the other members of RISC-V. It gives you more visibility and creates kind of a set of colleagues to work with and customers. You gain technical advantage from insights, and you can see what technical deliverables there are in motion. You can take your priorities and try to get those incorporated in the standard, so get the standard to be more applicable to what you do, and this will just basically, it helps you with your business return on investment. You reduce your technical overhead, and you can accelerate your roadmap with this global open standard. So it allows you to spend more money on your innovation. You don't have to spend it on such a wide range of activities so far. So there's, please, if anybody wants to think about membership, we have individual memberships as well as company memberships. So you can just join us. But also we have company and organization memberships, and the prices change depending on what kind of level you want to be, but also how big your company is. So we want to make sure that we're accommodating for companies large and small. If you want to find out more about RISC-V, please talk to me, or if you want, come along to RISC-V Summit Europe. This is going to be happening in Munich in Germany in summer this year. Last year we had about 550 people joining. It's basically a single track of talks plus an exhibition over 3 days. There's both a research and an industry focus as well. With Europe, in Europe, there's a lot of academic research going on with RISC-V, which is really good. And so we work with these people in the research field to put on the show, and we bring kind of some of the more industry focus together to sort of bring these together. And it's a really great event. So I hope, if you're interested, visit riscv.org. You can find a link to the RISC-V Summit Europe website. I hope to see you there. So that's basically everything I've got to say. I think I've got 1 minute.
It's the tea break now.
Okay.
Tea break now.
Hi.
You talked about Debian support. You mentioned Debian support, but it's presently unstable. Have you got line of sight to an accelerated progress to stable? Because if we're waiting for Trixie, we could be waiting quite a while.
I don't know personally, but I can find out for you, for sure.
If there is a program for distribution to be able to bootstrap their OS on RISC-V, for example, we are trying to bootstrap Rocky Linux to run on RISC-V.
Okay.
And basically, the only way to do that is running in QEMU, which is the same way that Fedora got Fedora running on RISC-V. The current boards that are available at the market, or the one that we can get our hands on, they are not as fast, and some of them are not very. They're still early stages, so there will be lots of iterations. Like I know some of colleagues from Fedora got the Milk V1, and they had some issue with specific bottlenecks, and they reported these issues.
Okay.
So basically, at the moment, the only way for us to bootstrap a distribution is literally using QEMU, and it's still slow because you are emulating QEMU on top of x86, basically.
Yeah, I mean, so I can speak to you maybe after we've finished and get you in touch with like my colleague Jeff Scheel, who runs the development boards program, because he is, he's working to get silicon to people who need it for doing, this kind of enablement. The people that I was speaking to, 10x engineers, they, as part of their RISC-V, the work they're doing towards RISC-V Labs, they're offering time on physical boards as well as emulation. So they have boards sitting on their, sitting in their lab, I guess, and you can remotely connect into it. So I'd need to check exactly how that worked, but I can make inquiries to see how we can help you out.
Thank you.
Can I ask a general question?
Please.
In what way is ARM responding to the developments within RISC-V?
You need to speak to ARM about that, I'm afraid.
But I mean, obviously, at some way there must be, maybe it's an IP defense or whatever, but I mean, what do you see as being the response from ARM?
I really couldn't comment, to be honest. I mean, they're just outside and you could speak to... yeah, as I say, it's not something I could really talk to.
No, but they're the dominant market. Yeah, okay. Yeah, Bill.
I'm sorry, that's a non-answer, but
No, okay.
I couldn't speak for them. Okay. Well, please, anybody wants to hear more about RISC-V, just kind of grab my arm and, yeah, I can help you out.